This is u1 theta 1. This is u2 theta 2. No, u12 vector already you know. So shall we take help of this one? So I'll make now the particle 1 to move with a velocity u12. Then 2 will appear at rest. So let's go back to the base again, the what we calculated, very important one. Okay, I think this is going to help us a lot. Or we'll calculate once again. What is there in that one? I'll proceed into the problem. At t equals 0, both are here. Even gravity, if you want to show it, it will not have any impact on the relative motion. So let me define first all these velocity vector. What is u1 bar? u1 cos theta 1 I cap, u1 sin theta 1 j cap, minus u2 cos theta 2 I cap, u12 bar will be u1 cos theta 1 plus u2 cos theta 2 I cap. And this will be u12 bar, no? So u1 sin theta 1 minus u2 sin theta 2 j cap. So call this as u12x. X component and y component. Then after this, I think you look at this, it all depends upon which velocity is greater, no? This will be. So I'm assuming this one. So how do it will be? This will be u12 x component. This will be the u12 y. So get the resultant. This is what I already told you, know what you have to do. Only you have to somehow you have to bring that velocity triangle. Problem solved. So call this as say some theta. Sin theta, cos theta is needed here. What is u12? This formula there. What is u like a u1x, u2x? That we know value. So what is sin theta? Let's define the term. So sin theta is equal to u12y by u12. Cos theta equal to u12x by u12. Keep it here. Let's come for displacement triangle. In what action u12 bar is directed? Along this one. So what can be this angle theta? Will it be greater than theta 1, less than theta 1? How to decide that? I think it all depends on the value, no? So definitely u12 bar. So I'll take the vector diagram. We wanted u12 bar, no? So this is u1 bar and this one is u2 bar. Minus u2 bar will come like this. Shift that u2 bar like this. I'll redraw it again. This will be u1. We'll take one reference line here. This is u1. This is u2 bar minus u2 bar. I'll shift the resultant vector u12 bar is now there's a horizontal. Okay, anybody can you say about the angle made by u12 bar? This was that angle, no? All alpha or theta, sorry. I'm writing in green color. And what is theta 1? Theta 1 is here. See, there's no other way. You have to fight with it. You have to draw diagrams. You have to analyze. Now look at this. This much is what? I got it. So definitely theta less than theta 1 or more than theta 1. Anybody seeing the diagram? Theta should be less than theta 1. Okay, now we can draw the diagram. Now I can draw the diagram. So here, let 1 will move with a velocity u12. And what I do, I'll keep the 2 at rest. So call this is A, B, and let this be M. This is what? That's theta. And there's a distance D. Is this perpendicular? Yes, it is. So what is minimum distance? There's a minimum distance. I think again and again what happened, I'm asking you to come to that velocity triangle, displacement triangle. These are just some vectors which you have to bring. Though gravity is present. Sir, what is this? Previously, first problem without gravity we discussed very fine. Now again here gravity is there also. You are no way bringing G because the relative accelerated motion, both are having acceleration G downward, no retardation, and that will cancel out. So projectile 1, when it looks at projectile 2, it will appear it moving with a constant speed. So what is the state of this? At rest. The 1 will move with a velocity u12 in this direction. Actually, one will move here. 2 will move like this, parabolic path. But when 1 looks at 2, what happens? It feels he's moving along the path u12 bar. I just gave one straight line. I said like, sir, how you can say straight line? As this one. 1 with respect to ground will move in a parabolic path. 2 with respect to ground, parabolic path. But when 1 looks at 2, in what direction you'll move? You'll move along AM. I'll give one more best diagram in the end. First, we'll end up with the answers here. Now, what is the minimum distance? So come for the mathematics. Sine theta. Sine theta is equal to S minimum by D. D sine theta. What is sine theta from here? U12 Y by only U12. What is U12? The magnitude of this. You want to magnitude if you want. What about the time? T equals 0, it is here, no? After some time T, it will be here. How to calculate that time? How to calculate that time? So U12 is equal to AM by T, no? That was that T, this is. So what is AM? So from this triangle cos theta equal to AM by D. So AM is equal to D cos theta. So what is the T is equal to? D cos theta by U12. What is cos theta? U12x by U12. So this will be our answers. So that displacement triangle, velocity triangle, that you don't forget. Wherever you go, displacement triangle, velocity triangles. There's nothing but I included relative velocity, relative projectile motion also here in this particular thing. You may ask, somebody may ask, sir, what actually going on here? What actually going on? So here, I'll take you to the very first diagram. So what is that AM? I'll take the green color one. So when projectile 1 looks at the projectile 2, there's a 1. You have, I think this path, all of you agree, parabolic path of 1 and 2. Because why? Because we know projectile motion. Now, sir, where you show that relative motion? I'll show like this. It need not to cross through point P. So we'll draw one line. Now, what is this line? What is the straight line? Anybody? Path of 1 with respect to 2. So what is this? Here I'll indicate. Path of 1. This is what? What is this? Path of 1 with the, so what do you mean by path of 1 with respect to 2? Projectile 1 looks at the ground. He feels he's moving in parabolic path. Projectile 2, when he looks at the ground, he feels he's moving in parabolic path. When projectile 1 looks at the projectile 2, he feels he's moving in this direction. Straight line. Can you remember the first statement? I brought there here mathematics. No, here you can see mathematics. This mathematics I concluded. Nobody will understand the green color. You look at here. Nobody will understand this, sir. What do you mean by this? Here, what I give exact picture here. Getting all of you. So this is about the mathematics. Here, what happened? The one, when it looks at the projectile, one looks at the two, it will move. Sir, what about the projectile two looks at one? Again, you work out. Somewhere here it will come like this, here in this direction. Then one will appear at rest. Is it okay? Say in books you have equations, huh? But what actually going on? This particular diagram, they have missed it. That's why the students find very difficult. So, okay, sir, like what is this relative projectile motion? This is a thing. Now, the first diagram. So if I draw in the beginning, no, you'll get confused. If we want to constant, sir, why you're writing? So I should take you back here. From the last conclusion is what I'm able to do it here. Okay, fine. I'll scroll up everything. You just see once. Huh? M will come somewhere here. No, the M should be perpendicular. Somewhere it will be. M will come somewhere here. The minimum separation. This is 2, no? So you further take this. So M will come somewhere here. It's a rough diagram, no? If you draw, you assume value U1, theta 1, U2, theta 2, then you can exactly tell where that M will come in the path. So from the diagram, the M should come somewhere here. Dot I'm putting, somewhere it should come perpendicular, no? Not up to the scale it is. This is again, you'll get confused. So theta, this is theta 1. Completed. So I'll scroll down. So there's the initial path.
Yes.
There's the mathematics. This, you know, it's a routine, no, the same velocity triangle. See, you see, there's a displacement triangle. There's a velocity triangle. Okay, shall I go for next one?
Yes, sir.
So nothing but if two projectiles projected, can we find out minimum separation between them? Yes, they're the one.